Good day, ladies and gentlemen, boys and girls, friends and neighbors. Let's talk about two special right triangles. The first type we're going to talk about today is going to be a result of some manipulation that we are going to look at from an equilateral triangle. So we're starting out here with an equilateral triangle. What do we know? What is an equilateral triangle? Well, an equilateral triangle, all the sides are congruent. I can mark them this way, if you will. And all the angles are congruent. Well, what does all the angles congruent mean? For every equilateral triangle, that means that all of the angles are 60 degrees. 60, 60, 60. 3 times 60 is 180. That's an easy thing. What we're going to do to get our first type of special right triangles is we're going to sketch this segment from this vertex to the midpoint of the opposite side. That is, we're going to sketch this thing that we used to call, well, we didn't used to call, we still call it a median. And this is a median. A median is a segment, a special segment of a triangle that you learned about in geometry that goes from a vertex, as this one does, to the midpoint of the opposite side. That says it's going to bisect this side, and these two segments here are going to be congruent. Well, what we learned with congruent triangles was that a median is also an angle bisector, and we're not going to prove that to you. We're just going to give you that. Could we prove it? You bet. We're just going to remind you that a median in an equilateral triangle, keep in mind this is an equilateral triangle, don't forget. If you have an equilateral triangle, as I do, a median is also an angle bisector. Well, what does that mean? Well, what that means is that this angle right here is going to be a 30 degrees because it's an angle bisector. And this angle here was 60 as the other two angles were. I have an angle bisector. Half of 60 is 30. A median is also then what we call a perpendicular bisector. We could prove that with congruent triangles as well. What does a perpendicular bisector do? It does exactly what it's named. It bisects a segment perpendicular. That means, oh, I've already got the bisecting going on here with the median, but special in that this makes a 90-degree angle. Well, look, if it was an angle bisector, it had to be a perpendicular bisector because now I'm looking at this 30, 60, 90 triangle. And this angle had to be 90 since this was 30 and this was 60. That's all I had left with. What we're going to do is we're going to look at this we're only going to look at now at this 30, 60, 90 triangle. Let me erase that. So we're going to come down here and we're only going to look at a 30, 60, 90 triangle. Sketch the best I can. That's not too bad. And what do we know? Well, we know that that's a 90. We know this is going to be a 30, 60, and this is going to be a 30. And I will tell you, no matter what the hypotenuse is, let's call it A, this short leg, because we started with the equilateral, and because the segment that's perpendicular from that vertex to the midpoint this side right here has to be 1/2 A. And that stems completely and absolutely from this property of equilateral triangle and a median. So if this hypotenuse, if this length here, whatever we want to name it, if that length is A, this length right here has to be 1/2 A. That's an important property of equilateral triangles, and we're going to use that property in a 30, 60, 90 right triangle, which is actually 1/2 of an equilateral triangle. So what we're going to do now is we're going to use a little algebra in the Pythagorean theorem. We're going to find this long leg. Oh, well, what is that long leg? That long leg, then, we'll do just the Pythagorean theorem, which we've been reviewing. B squared plus 1/2 A squared is equal to A squared. Well, what is 1/2 A squared? This is B squared. 1/2 A squared is 1/4 A squared is equal to A squared. I'm going to try to solve for B here. So what am I going to do? I'm going to subtract this 1/4. That tells me B squared is equal to A squared minus 1/4 A squared. Well, tell me, A squared minus 1/4 A squared is 3/4 A squared. And that's what B squared is equal to, 3/4 A squared. If I square root both sides, I want to get B is, well, it's going to be the absolute value of B here. But keep in mind, since we're in a triangle, B is always going to be positive. B cannot be negative. And so B is going to be the square root of 3. Actually, the square roots of 3/4 and the square root of A squared. So, look at this. This is going to be the square root of 3. Square root of 4 is 2. Square root of A. So that tells me that long leg can be found by just taking square root of 3, times A. So this long leg is square root of 3 times A. So let's go to the next screen and show the results about type 1. And type 1 of special right triangles is 30, 60, 90. The type 1 is going to be the 30, 60, 90 right triangle, 30, 60, 90. What do I know? This triangle has a small leg, a long leg, and a hypotenuse. And the short leg is always 1/2 the hypotenuse. And the long leg, log leg, that's funny. The long leg is always square root of 3/2 times the hypotenuse. This is always true. And I have to tell you, this is going to be extremely useful next week and the weeks to follow. So here's one example. What if I have a 30, 60 right triangle? Where the hypotenuse is 1. So this is a right angle here. That's 60. This thing has to be 30. So now I have a 30, 60, 90 right triangle. And I'm just going to say, hey, for this example, let the hypotenuse equal 1. What do I know? Well, y has to be half of 1. Y is 1/2. X has to be square root of 3 times 1. Square root of 3/2 times 1. Extremely, extremely important. So this is a specific case of the 30, 60, 90 right triangle where the hypotenuse is 1, short leg is 1/2, long leg square root of 3/2. For all of the 30, 60, 90s, this would be your result. Okay. Where did that come from? Keep in mind, anytime you want to pause the video, just pause the video. Where did this come from? Don't forget, this came from the fact that a 30, 60, 90 is 1/2 of an equilateral triangle. So let's look at our type 2. Our type 2 triangle is going to be an isosceles right triangle. What in the world, you didn't think you'd be doing geometry again. What the world is an isosceles right triangle? Well, an isosceles right triangle, it has to be right, hello, hence its name. An isosceles means it has two congruent sides. And this particular guy right there, and the hypotenuse has to be the side opposite the 90-degree angle. And what do you know about an isosceles right triangle? Well, the legs are congruent because it's isosceles. It has one right angle because it's a right triangle. And the base angles also have to be congruent because that's a property of isosceles triangles, is that the angles opposite the congruent sides are congruent. Well, since it's a right triangle, what's the measure of the base angles? The base angles are 45 degrees. 45 plus 45 is 90, plus 90 is 180. So there's our other special type of right triangle, is we're going to call it a 45, 45, 90. Let's investigate. All right, well, let's let the hypotenuse this time be A, as we did before, and we're going to let this other, the two legs are congruent. We'll just let them both be B. What do we know? Well, by the Pythagorean theorem, you know that b squared plus b squared is a squared. That's just the Pythagorean theorem. B squared plus b squared is 2b squared. Divide by 1/2, or divide by 2. Don't divide by 1/2, that's 2. Divide by 2 is 1/2 a squared. Take the square root, and I get the square root of 1/2 times a. Square root of b is b. Square root of b squared is b. Square root of a squared is a. And keep in mind, everything's positive, so I don't need the absolute value. Now, this guy right here, this is a funky thing. Well, the square root of 1 is going to be the square root of 1 over square root of 2, which is this guy. And I don't like square roots on the bottom, so look what I'm going to do. I'm going to take this dude right here, which is 1 over square root of 2, and I'm going to change the way he looks by getting that square root of 2 out of the bottom. And how do I do that? I'm going to multiply by this dude right here. And what is this? Who is this guy? Yep, that's 1. So I have 1 over square root of 2 times 1. In the form of square root of 2 over 2, I get 1 times square root of 2 is square root of 2. Square root of 2 times square root of 2 is 2. And so this b then is square root of 2 over 2a. That's what b is. So that's a pretty darn easy property. If I have an isosceles right triangle, a leg is square root of 2 over 2 times the hypotenuse, and that's the result. The result of type 2, 45, 45, 90. The leg is square root of 2 times the hypotenuse. It doesn't matter what this guy is right here. Doesn't matter what he is. Say he's K. This guy here is square root of 2 over 2 times K. As this guy is square root of 2 over 2 times K. Well, here's one nice example. What if I have an isosceles right triangle where the hypotenuse is 1? What's the length of the side? Square root of 2 over 2 times, oh, yeah, square root of 2 over 2 times 1, which is just square root of 2 over 2. Okay? All right, pretty easy result two special right triangles, 30, 60, 90, 45, 45, 90. We will use those a lot in our study of fundamental trigonometry. So I bid you farewell. Have a great day.